Hello and welcome to Autocad Beam Tutorials. In this AutoCAD tutorial, I am going to explain all the keyboard function keys, and I hope it will be useful for you. In AutoCAD, every F key has a specific function assigned to it. Let's make an overview. After that, we will go into details for each one. You see all 12 keys and their functions in this list. F1 simply displays the help window, just like it does in any other software. F2 opens or closes the AutoCAD text window, which shows the history of command line entries. F3 key turns object snapping on or off. F4 is for 3D object snap in AutoCAD. It toggles 3D object snap on or off. On the other hand, it has a different function in AutoCAD LT, it turns tablet mode on or off. It is different in LT, because LT is just for 2D drafting, not 3D. F5 changes the isoplane setting. F6 toggles dynamic UCS. Note that it doesn't work for AutoCAD LT. It has no function in LT. F7 turns grid on or off. Next two ones, F8 and F9 are related with the cursor movement. F8 toggles ortho mode. F9 toggles snap mode. Here you should note that snap and object snap are different things. F10 toggles polar mode on or off. F11 turns object snap tracking on or off. F12 toggles dynamic input. Okay. Now let's examine each one in detail. F1 help window. It simply opens the help window. If you use AutoCAD Exchange, it opens Exchange window and needs server connection. In my case, I have no connection and clicking connect doesn't work. I am going to use offline help. Enter OP for Options window. Go to the System tab. Here you have AutoCAD Exchange menu group. You have an option for accessing online content, including help, where you can activate offline help browser by unchecking Access Online option. Uncheck it, and you have browser options here. I will proceed with Explorer and click OK. Let's hit F1 key again. Now you have the help content opened in Explorer. I won't go into detail about the help content, you can simply navigate inside it as you'll wish. And that's it for the help key. F2 expanded history. F2 opens or closes AutoCAD text window, which shows the history of the command line entries. You can see here all the commands or any keystrokes entered during this session of this specific drawing file. You may need to remember any data, especially some numeric data that you entered before, or come up with before while you are still working on this file, and then you can simply apply for F2 key. Note that it does not store the data after you close the drawing. You will have a clear window if you close and reopen the drawing. You can close it from here or you can just hit F2 key again. And that's pretty much it for the F2 key. F3, Object Snap. Object snaps are used to specify precise locations on objects, like midpoint, endpoint, or center. You can specify an object snap whenever you are prompted for a point. For example, when you draw a line. By default, a marker and a tooltip are displayed when you move the cursor over an object snap location on an object. F3 key opens or closes object snap mode, that is, it activates or deactivates snapping feature. You can't see snap locations when object snap is off. Here you also have an Object Snap button which works for the same function. Click to open or close a snap mode. Object Snap locations are set with Drafting Settings window, which I won't get into detail in this tutorial. Let me just show its location for now. Right-click on the Object Snap button here and you see all the snap location options, and if you click on Settings, it opens Drafting Settings window and Object Snap tab. And that's it for the F3 key.
F4, 3D Object Snap. F4 key turns the 3D Object Snap feature on or off in AutoCAD. You can also use the status bar icon for the same function. We have just examined the Object Snap feature for 2D drawing environment. Now it is time to see the Snap feature for 3D objects. As the name clearly implies, 3D Object Snap feature let us snap at specific points on 3D objects when we are creating or moving other objects. Just like 2D Object Snap, 3D Object Snap has its own specific snap modes. You can see the modes again in Drafting Settings window, this time under 3D Object Snap tab. Go to 3D Object Snap icon and click the arrow adjacent to it. Here you see the list of all 6 snap modes. You can activate or deactivate each one as you need with clicking on it. Click Object Snap Settings to get the settings window. Here you see the modes for 3D objects and point clouds. A point cloud is shortly a group of 3D points taken from real-world spaces. Hover the mouse over the modes to see their explanations. You can set the modes by checking or unchecking the boxes as you need. Let's try it on a solid box. Click the box tool or enter box as the command. Draw the base and give some height. Hold down the Shift key and the mouse wheel at the same time, and move the mouse to get in 3D environment. Change the visual style to conceptual to feel the solid. Make sure 3D Object Snap is turned on. Use line command to see the different snap points. Now let's draw a polyline from the center of this face. Turn on Ortho mode for a perpendicular line. Now continue with using the perpendicular, midpoint, and center snaps respectively. And finish again perpendicular to the box. You can use this polyline to apply sweep command for example. Create a circle as the sweep object. Turn on the dynamic UCS feature in order to use this face as the creation plane. Note that the plane becomes blue. It means that the UCS is now set to this plane. Create a small circle. Now execute sweep command. Choose the circle as the sweep object and the polyline as the path. And this is the outcome. Okay, that's all for F4 3D Object Snap key in AutoCAD.
F4, Tablet Mode, for AutoCAD LT. F4 key works for opening or closing the tablet mode in AutoCAD LT. What is meant by the word tablet is a digitizing tablet attached to your computer. A digitizing tablet is simply an input device that enables you to enter drawings and sketches into a computer. A digitizing tablet consists of an electronic tablet and a cursor or pen. How it works with AutoCAD is subject of another tutorial. So, if you have a tablet attached, you can activate or deactivate tablet mode in AutoCAD LT with F4 key. When I enter F4, it says calibrated first. And because I have no tablet device attached, I cannot calibrate anything. You can also check the tablet command and options for current pointing device selection. If I enter tablet, it says your pointing device cannot be used as a tablet. Because my pointing device is only the mouse right now. Enter OP for options window, or right-click in the command line area and select options. Under the System tab, you see the current pointing device section. You can assign the device here, and change accept input from option if you have a digitizer attached. You can manage tablet settings also under Tools menu. Here you can turn it on or off, calibrate or configure. And that's all for F4. F5, Isoplane. Isoplane command specifies the current isometric plane. In AutoCAD, the crosshair cursor is set to be vertical and horizontal to the drawing screen or plane, as the default option. This means that you are in the rectangular snap mode, and you can draw lines, for example, vertical or horizontal to the screen, when the ortho mode is on. By the way, you can turn on or off the ortho mode with the F8 key, which we will examine later in this course. With isoplane settings, you can change the crosshair cursor lines to be isometric, that is to say, at an angle of 30 and/or 150 degrees. In order to draw isometric lines, you need to turn on the isometric snap feature. For this, you should change the Snapstyle system variable to 1. Another way is to go for Drafting Settings window, and under Snap and Grid tab, in the Snap Type Options menu, to choose Isometric Snap. This is an isometric drawing. Isometric drawings simulate a 3D object from a particular viewpoint by aligning along 3 major axes, as shown here: A, B, and C axes. Although the isometric drawing appears to be 3D, it is actually a 2D representation. This seems as a 3D cube, but actually it is not. By setting the isometric snap on, you can easily align objects along one of 3 isometric planes, which are top, right, and left planes as you see. You can cycle through the isometric planes by pressing F5 or Ctrl+E. You can also use Isoplane command. Enter T for choosing the top plane. L for left. R for right planes. Using the F5 key is obviously much more practical. The ortho mode must be turned on in order to be able to draw isometric lines. If the ortho mode is off, then you can draw lines in every direction and there is no meaning. Choosing one of the 3 isometric planes causes ortho and the crosshairs to be aligned along the corresponding isometric axes. When you are at the top plane, you can draw lines at the axes of A and B. Not in C axis, because it does not belong to the top plane. If you change to right plane, then you can draw in the axes of B and C. Change to left, and you can use A and C axes. That is the logic of isometric drawings. And that's pretty much it for the F5 key.
F6, Dynamic UCS. F6 key turns on or off Dynamic UCS feature in AutoCAD. Note that it has no function in AutoCAD LT. Because this is something related with 3D environment, and LT is for 2D only. You can also use the status bar button to change it. Click to turn on or off. UCS, that is User Coordinate System, is the active coordinate system that establishes the X and Y work plane and Z-axis direction for drawing and modeling. With Dynamic UCS feature, AutoCAD can automatically resets the UCS according to 3D objects in the drawing. And this really becomes a time saver while you work with 3D objects. Let's see it on a 3D solid object. Create a box. Now this is the active UCS. When I draw something, AutoCAD uses these X, Y, and Z coordinates. Let's say I need to draw a cylinder on this face of this box. Then I need to change the UCS in order to take the face of box as the base plane. I can do it manually with redefining X, Y, and Z directions, or more practically with using Face UCS tool. But Dynamic UCS feature automatically changes it for you when you move the cursor over a face. Now first let's see what happens when Dynamic UCS is off. Execute cylinder command. Let's change the visual style for a better understanding. Hidden style will be better, I think. Yes. Now cylinder command again. Go over this face and create the cylinder. You see, it is not what we want. It is taking the active XY plane as the base, regardless of the box. Try other face. Now let's turn on the Dynamic UCS mode, and see what is going to change. You see now when I go over any face, it is being highlighted with blue, representing the new XY plane. Now I can easily create the cylinder on this face of the box. And on the other two as well. This is the logic of Dynamic UCS, and that's pretty much it for the F6 key.
F7, Grid Display. Normally, when you start a new drawing, it comes with the grid open. F7 key simply turns the grid on or off. You can also do it by clicking grid on the status bar. Or, by using the grid mode system variable. Enter value as 0 for turning it off, or 1 for turning it on. Grid properties are subject of another tutorial. So, I won't go into details of grid, but I just want to show the location of the grid properties menu. Go for drafting setting window. Right-click and click Settings. At the first tab, here you have the parameters of the grid system. Let me also show how you can change the grid line colors. If you use a black colored background like me, then the default grid line colors are not clearly visible. To change the colors, go to Options menu. Right-click and Options. In the Options window, go for Display tab, Window Elements menu group. Click Colors. In the 2D model space context, highlight grid major lines and minor lines and change the corresponding color as you'll wish. Apply and close. Click OK. Now, you see the grid more clearly. And that's it for the F7 key. F8, Ortho mode. F8 simply turns on or off the ortho mode. You can also use the ortho mode button in the status bar. Or, ortho mode variable works for the same function. Enter 1 to turn the ortho on, or 0, for turning it off. But, of course, this is not practical to use. Now let's talk about the ortho mode, that is, orthogonal locking mode. You can restrict cursor movement to horizontal and vertical for convenience and precision when creating and modifying objects. For example, when drawing a line, if the ortho mode is on, you can draw lines at an angle of 0 or 90 degrees. When it is off, you can draw to any direction. As you move the cursor, the rubber band line follows the horizontal or vertical axis, whichever is nearest the cursor. The orientation of the current user coordinate system, UCS, determines the horizontal and vertical directions. You can use direct distance entries with ortho mode turned on to create orthogonal lines of specified lengths or to move objects specified distances. Let's open the grid to easily see this as we practice it. Make sure the snap feature is on in order to be able to select the grid points. Note that the distance between the major grid lines is 50 unit. Enter L for line. Click for the start point, do not click for the end point. Instead, enter the value for the length you want the line to have. Let's enter 100. Escape to go off the line command. Select the line and go for the properties window by Ctrl+1. Here you can check the length, 100 as we entered. Let's see it with move command this time. Enter M for move command. Select the line. Right-click to finish the selection. Click anywhere to specify the base point for the displacement. Do not click for the second point, instead, enter a value for the distance that you want the line to be moved. Say 100, enter and you see the line moved exactly 100 unit vertically. You can turn ortho on and off at any time during drawing and editing. Ortho is ignored when you enter coordinates or specify an object snap. To turn ortho on or off temporarily, hold down the temporary override key, which is the Shift key. While you use the temporary override key, the direct distance entry method is not available. If turned on, the isometric snap setting takes priority over the UCS in determining horizontal and vertical directions, as we saw in F5 Isoplane key part of this tutorial. You should also note that, ortho mode and polar tracking, which we will see as key F10, cannot be on at the same time. Turning on ortho turns off polar tracking and vice versa. And that's pretty much it for the F8 key. F9, Grid Snap. F9 key simply turns the snap feature on or off. You can also use the Snap Mode button here in the status bar. Click to turn it on off. Or you can execute the system variable, which is Snap Mode, just like the other keys we have seen so far. Enter Snap Mode. Value 0 turns the snap off, whereas values 1 and 2 turns it on. Now let's talk a little about the logic of snapping. Snap Mode is very related with the Grid Mode in AutoCAD. You can snap to a rectangular grid, to enhance drawing speed and efficiency. As we have seen, the grid is a rectangular pattern of dots or lines that extends over the area you specify as the grid limits. For a dotted grid, go to Drafting Settings, Snap and Grid tab. Here under Grid Style menu group you have Dotted Grid Display options. Check 2D Model Space. Click OK, and you have a dotted grid now instead of lines. Using the grid is similar to placing a sheet of grid paper under a drawing. The grid helps you align objects and visualize the distances between them. Snap is useful for specifying precise points with the arrow keys or the pointing device. Snap Mode restricts the movement of the crosshairs to intervals that you define. When Snap Mode is on, and the snap type is defined as Grid Snap, then the cursor seems to adhere, or snap, to grid points. The grid may be visible or not, doesn't matter. Grid Mode and Snap Mode are independent but are often turned on at the same time. Snap spacing is set in the Drafting Settings window, Snap and Grid tab. Here you have spacing value fields both for X and Y directions. Spacing means the distance between snap points in AutoCAD units. If it is 10, then you snap at every 10-unit distance in both directions. As the default, the snap spacing and the grid spacing values are the same. That led us to use the grid points or junction point of grid lines as the snap points. You should not assign a value different than the grid spacing for the snap spacing unless you really need it. If you have a different value, then your snap points will be independent of the grid system. It will have its own invisible grid. Now let's check the Polar Snap feature. You have two options as the snap type, Grid Snap and Polar Snap. If you change it to Polar Snap, then the logic of snap points changes. Grid Snap type was related with the grid system. Polar Snap type, on the other hand, is related and must be used together with the Polar Tracking feature. You need to turn on Polar Tracking mode in order to be able to use Polar Snapping. Polar snap restricts cursor movement to increments of a polar distance you specify. For example, if you specify a length of 4 units, the cursor snaps from the first point specified to lengths of 0, 4, 8, 12, 16, and so on. As you move your cursor, a tooltip indicates the nearest polar snap increment. Polar angle parameters are subject of F10 key that we will see as the next chapter. Let us check it also with the grid turned on. Draw a line. Start with the origin point to catch the grid point. Enter 0, 0 for x and y values, without clicking anywhere. That starts your line from the origin point. Remember the grid line spacing is 10 units in both directions, and the polar distance value is set to 4. Move your cursor slowly, and you will see the snap points at 4-unit intervals at defined polar tracking angles. And that completes it for the part of F9 key. F10, Polar Tracking. F10 key turns the polar tracking feature on or off, as we have already seen in the previous grid snap chapter. Like the others, you have the status bar button here. Click it to turn polar tracking on or off. When you are creating or modifying objects, you can use polar tracking to display temporary alignment paths defined by the polar angles you specify. Polar tracking restricts cursor movement to the specified angles. Polar tracking settings are in the Drafting Settings window and Polar Tracking tab. Here you can turn it on or off. Here you can assign the increment angle. This value defines at which angles polar tracking alignment paths are to be displayed. You can choose from the drop-down list any angle you want. Or you can assign additional angles here, click New and enter the number you want. For 30-degree increment you will have alignment paths at 30-degree intervals. If you define an additional value, then that value, only itself, will also be added to the options. For example, let's say we want a line at the angle of 52. Go to Additional Angles and assign New as 52. OK and exit. Now you will see 52-degree alignment besides 30-degree intervals. You can assign the increment degree here with right-clicking to Polar, more practically. You can also change the angle while you are drawing. You can start a set of lines, let's say with 30-degree angle, and without exiting the line command, you can change it to 45 for example. That gives you flexibility to draw any angle and distance that you want. Before we finish, remember when ortho mode goes on, polar mode automatically goes off. You can't have both turned on. And that's enough for F10 key, I think.
F11, Object Snap Tracking. You can turn on or off Object Snap Tracking with F11 key in AutoCAD. You can also use the status bar icon, of course. Here you have it next to Object Snap. Click to open or close. Object Snap Tracking works in conjunction with Object Snaps. You must have Object Snap turned on. You can only use active Object Snap modes for Object Snap Tracking. To set the object snap modes, go to Object Snap icon at the status bar. Right-click, and you see here all the modes listed. The ones that are turned on are highlighted with blue. You can add or remove by clicking on the ones that you want. You can also see them in Drafting Settings window, Object Snap tab. Right-click on Object Snap, and go to Settings. Here you have all the modes. Check the ones you want to be active. You can select all, or clear all. You can draw objects in specific relationship to other objects along specified directions called alignment paths or tracking vectors. Now let's see some examples. Let's say we want to draw a rectangle with lines. Enter L for line command. For the third line, you need to match the y-coordinate value of this endpoint of the first line. You need a tracking vector from this endpoint. Make sure the endpoint snap mode is turned on. Hover the cursor over the endpoint to see the green box. Without clicking, go away. Notice the small green plus sign created at the endpoint. That means you have just acquired that point. You need to acquire an object snap point in order to create a tracking line. Now come here till you see the green tracking vector, and a small white cross sign as the offered snap point. You can click when you got the snap point marked. Now you have aligned the third line with the first one. Finish the rectangle with the next line. For the second example, let's create another rectangle. Now let's say we want to create a circle in the exact middle of this rectangle. You can do this with creating construction lines. Draw lines at the middle points and use the intersection point as the center for the circle. But this is not practical. The easy way is to use object snap tracking. Make sure the midpoint snap mode is turned on. Execute circle command. Now hover over the midpoints to create the tracking vectors. First one. And the second one. Make sure you see both green plus signs. Then go to middle to see both green tracking vectors and the white cross at the intersection point. Click for the center and finish the circle. Now you have a circle positioned exactly in the middle of the rectangle. Okay, let's do one more example. Create a line. Let's say you need to define a point, vertically aligned with this endpoint, and at a specific distance, say 50 units. To do this, we will do the same thing. Go over the endpoint to create the tracking vector. Now you need to arrange the distance. At any point below, while you see the vector, simply enter 50. And you have your point at the desired position. Click for a parallel line, for example. Let's check the distance. And that's pretty much it for F11 key. F12, dynamic input. F12 key turns on or off the dynamic input feature. You can't see any text in the command line, but you can see the status bar button highlights. You can also click the button on the status bar to turn it on and off. Let's examine it with line command. Normally, the text you enter is shown at the command line area. With turning on dynamic input, AutoCAD provides a command interface near the cursor to help you keep your focus in the drafting area. You don't need to look at the command line anymore. The prompts are also displayed here. Use bottom arrow key on the keyboard to see the prompt options, if there is any. When dynamic input is on, tooltips display information near the cursor that is dynamically updated as the cursor moves. When a command is active, the tooltips provide a place for user entry. After you type a value in an input field and press Tab, the field then displays a lock icon, and the cursor is constrained by the value that you entered. You can then enter a value for the second input field. Alternately, if you type a value and press enter, the second input field is ignored, and the value is interpreted as direct distance entry. Dynamic input has three components, which are pointer input, dimensional input, and dynamic prompts. Right-click the Dynamic Input button and click Settings to open Drafting Settings window, Dynamic Input tab. Here you can control what is displayed by each component when dynamic input is earned. Or, you can disable any of the components by unchecking the options. You can also set the appearance of the tooltip. One last thing to say about dynamic input is that you can turn it off temporarily by holding down the F12 key. The temporary override key is again F12 itself. That's all for F12 key, and it completes this tutorial. Thank you for watching. You can leave any comments or questions. And if you like this video, you can subscribe to my channel. I will keep posting CAD BIM tutorials. Bye for now.